By the way, I was looking at the textbook, and the textbook has us covering week 15. I forget what it's called. Let me look at it real quick. Java FX and Scene Builder. Now, I'll let you know, I have never yet in my Java career used FX or Scene Builder. So I'm playing around with altering the content for the last week and maybe doing some integration of web development and Java. Okay, if we do that, it'll be just some basic stuff, how you can generate a page, and I will put out all of the basic frameworks for you so you don't have to mess with too much. All right, so arrays in general. Arrays is a mathematical term, right? Anyone ever heard of arrays before in your, I guess, trigonometry classes? You've heard about it in geometry? Yeah. What is an array to you? What's that? A list. It's pretty much what it is. It's good to think about arrays in terms of boxes, memory locations, a collection of memory locations. And that's why we often say a list of memory locations, right? It's a specified number. Arrays will always be specified. They'll always be a set amount. So, of course, today we're going to look at declaring array, how to initialize an array. We'll use some variable subscripts. These are the indices that we specify in an array. We'll talk about declaring and using different objects in an array, and we may or may not get into today, probably on Thursday, we'll get into searching an array and parallel arrays and multi-dimensional arrays and all that fun stuff. Okay, so declaring an array. Pretty much what you see right here. You have the primitive type or the object type with the brackets and then some type of variable name. The variable name is what you're identifying that array to be. So an array is a list of data items, and we call these data items elements. Okay? So as you iterate through an array, you're iterating through the elements in that array. All data items in an array, they are the same type. You can't, this isn't like in JavaScript where you can have JSON objects. And in a JSON object, you can have different types of data. This isn't like that. In Java, an array, everything has to be the same type because you're replicating it across memory. When you declare an array variable, it's the same way you declare any other variable. So you declare the type, bracket, and then the variable name. You always use and insert the square brackets after the type. Okay, very basic stuff. Now, when you declare an array, you still have to reserve the memory location. And with a primitive, if you have int cell equals 0, usually when you use primitives like that, that's how you reserve memory. You don't necessarily say int cell equals new int. You don't do that with primitives. But with arrays, you do. And you'll notice that the subscript here it's actually double cell equals new double, and then the brackets again, and then you have the subscript of 20. Now, what 20 is saying here in this subscript is the subscripts will always be integers. You'll never pass in other data types. In an array, the subscript will always be integer. Okay, so that does have some limits on how big an array can be if you think about it, because how big can an integer be, right? All right, so if you have, say for example here, we have double sale equals new sale. We're specifying 20 elements. That's the subscript. That means that if you call anything outside of 20, you're going to get an error. And the error will be some type of index array out of bounds error, right? This will be the error message generated. Now Java, again, it protects you. In C++, you may or may not get that error, and you'll probably access someone else's data when you do that, because it's not very secure that way. In Java, it's very secure. When you specify the amount, if you try to call outside of that amount, it's going to tell you no go. All right. Let me give you another example here. So with an array, their elements are numbered. They begin with 0. Now this is always the part that catches every developer. They think, oh, I'm going to start with 1, 2, 3, 4, and they get up to 20, and they get an array index out of bounds, because 20 is actually 21. When you're specifying the index inside of an array, that subscript variable, you always begin with 0. So when I say give me the first element of an array, you would say give me the subscript 0 of that array. Does that make sense? Now always remember it begins with 0. So for example, if you have an array that begins from 0 to 19, you have 20 elements in that array. 20 elements. And so sale bracket 0, close bracket, is element 1. Cell bracket 1, or cell bracket subscript 1, is element 2. And on until you get to cell bracket subscript 19 is element 20. Now, when you're using individual array items, you can specify the element number like it's any other value. So, for example, in the PowerPoint slide that we have on the board right now, I could say cell subscript 0, index of 0, equals this number. And that's totally valid. You can do that. In fact, this is how arrays are usually are handled. All right, so here you have another, this is just breaking out into boxes, and you can see that each of these boxes represent the subscript for that element. So cells figure subscript 0 is at the first position on, and then it has a little break here signifying that there's a bunch more in between, right? So you get up to 19, which is position 20. So a variable with a reference type such as an array, it holds a memory address where that value is stored. Always think about your RAM that you've spent, those hundreds of dollars for, and you've bought and you've put inside your PC. Somewhere on that piece of RAM is where your memory location is stored, right? And the same thing with an array. It's going to take up slots of memory specified. You're telling it exactly how much memory, the scope of it, because you've declared the type, you've declared the number of subscripts that it'll take up. So it's a memory address. So array names, they represent computer memory addresses. They contain the references to those locations. When you declare an array and you don't assign anything to it, it's the same as saying, for example, double cells bracket equals null. It's giving it the assignment of null is the same as saying double cells bracket semicolon. And again, the Unicode value for that is the \U0000 subscript. Okay. Using the keyword new, this tells the JVM to go grab that piece of memory location. Because now I'm going to actually tell the JVM how many pieces of memory to grab. So when I say int sum nums equals new int 10. So go grab JVM 10 pieces of memory for me to store this data. That's what we're telling it. And so each element of sum nums when they're initialized, they have a value of 0. If you remember, if I declare any int and I don't specify a value, it's automatically going to hold the value of 0. It's the same thing here for the array. All of the array values will all hold 0. Char elements, they're going to be assigned that beautiful Unicode value there. Boolean values will automatically be assigned false. So you could have an array of Booleans. String arrays, they'll automatically be assigned the null value. Excuse me. I had a strawberry milkshake before I came, and when you drink a Coke and strawberry milkshake together, y'all didn't want to hear about that, did you? All right, so here's the other way you can initialize an array. I'm not trying to rub it in that I had a milkshake and you all didn't, but so here we have int bracket, and we have this name 10 mult, which is basically their abbreviation for 10 multiples. And they're using the curly bracket syntax with the actual number, comma, number, comma, number, comma, number, so on, right? And then they close the curly bracket and then semicolon. This is the other way that you can specify the elements for an array. You could do this through strings. You could say string bracket names equals curly bracket John, Christian, Jessa, Samuel, Omar, Mike, right? Gentlemen, all these names. You could initialize it the same way, and it would take up those specified pieces of memory in RAM. All right, so this is also known as an initialization list. It initializes the array. So if you already know what the values are going to be up front, then you would do this. That's how you would initialize it. Populating an array like this, it provides all of the variables up front. Now you can as well overwrite these values. Now think about it. How would I overwrite the number 30 in the array called 10 mult? What would I do? How would I overwrite that? Just using a regular left assignment. What would I say to overwrite it? Be 10 mult, bracket, and then what subscript? Mike, I know you're thinking about it. What? So remember, they all count by 0, right? 0, 1, 2, 3. So if the number is 30 in this array that's up here, what would I be? 10 mult, bracket, 2, and then I'd say equal sign whatever I want to change that value to, right? Okay. So using variables, the variables in an array, this is what makes it powerful, because you can iterate through an array by those subscript, those indices. So if I know that I have 5 elements in an array, I know that my first indice will be 0 and my last will be 4. Very good, right? And so I could say int I equals 0, I is less than 5, I plus plus, and then I could specify the array and iterate right through it. And I could add to that, I could populate it, I could also spit out the value that's in that array by using the loop. That's why arrays are so powerful. They're very, very nice. Very, very nice to have. Now, the one catch with an array is that once the array is set, you can't resize an array. You have to create a brand new array and then pass the values over to it that you want in order to resize it. Now, Java has some APIs that do some of those things in the background. For example, a vector does exactly that. It allows you to store things in a vector class, but underneath it's just an array. And so what it does is it says Up front, I'm going to initialize you with 20 objects, and then once you get to 21, it says, oh, he's at 21, she's at 21, there's no 21st object, so I'm going to create a new array under the scenes, reassign all the other values, and give them another 20 indices, another 20 subscripts, right? That's using a vector. But right now, we're just using an array. All right. So when an application contains an array, use every element of the array in some task. You don't want to just create an array if you're not going to specify what the size of it is, because arrays are really made so that you have to specify the beginning and the end. If I have a class of 20 students and I'm going to create an array, I wouldn't create a class of 21. I would create a class of 20 students. And if I reached a point where I needed 21, I would have some mechanism, some other code logic that would create a brand new array of 21. You know, it's a matter of memory management is what it comes down to for arrays. All right, so perform loops that vary the loop control variable. So we always start at 0. You'll always, always, always start at 0. You're never going to start at 2 or 1 unless you have some other program logic where you know something, a variable is going to start at 2. But generally, when you're going to go from the beginning of an array to the end, you always start at 0. So this is also gets to this other idea of symbolic constants. So if we know an array is 5 variables long, then why don't we just create a constant for it, right? All right. The variable itself, the field itself, the array, it also has some variables available for you, like the length field. And what length will do is tell you the number of elements in the array. It'll give you the count, not the subscript count, because the subscript count will always be one less than what the actual length is. The length will always be the total number. So if there are 0 to 19, length will return 20. If there are 0 to 2, the length will return 3, right? It always returns the length of the array. All right. And then you have some things, some cool things you can do with for loops. All right. Now this is important. This will be one of the items on your test, how to use the enhance for loop. With the enhance for loop, you can skip a lot of the previous logic that you use. The for loop, this enhance for loop, already uses the length value behind the scenes to know how many iterations it needs. And so you're basically specifying a value that's going to be used to iterate across the subscript, and then you'll use that. So int value, score value. So in this example, int value must be of the same type as the array. So if my array was of type string, then my for loop would be string value, right? If my value was a custom class, say that you create a class, custom class called employees, and you have an array of employees, then for this variable, that first iterator value would have to be employee space value colon some array, right? They always match. All right, any questions there? No? Okay. All right, so let's look at an example. So we have a new score variable created. It's of type int. It's an array variable of type int, right? It specifies 10 indices, 10 elements. We have score equals 0, count equals 0, and total equals 0. And then we have this final int declaring a constant called quit which is our sentinel value of 999. We have another constant called max, which is of type int, which equals 10. And we're going to tell it to iterate or do something with those values. So we take a scanner, we're reading in the input, enter a quiz score or quit, which is 999, to exit. All right, let's look at the rest of the code. So we get the next int, we read it to score, while score is not equal to quit. So whatever the value you enter, if it's not equal to 999, yeah, make sure I'm saying it right. Then we go to the next value. So we're assigning the score to the count score. So right now, if you remember, let's go back one slide. The count right now is 0, and so we're saying at indice 0 or subscript 0, assign the score to the score array. Make sense? Then we're saying get the score and add it using the plus equal to the total. So that's basically the same as saying total equals total plus score. That's what that means, right? We increment the count, so now the count is from 0 goes to 1. If the count equals max, and max was what? 10. Yeah. And then else, system out print line, enter the next quiz, and so on and so forth, right? Okay. I know some of you guys are getting tired. I can see it in your eyes. This is such scintillating topic that you guys are excited about it, right? Yeah. Did you guys just eat lunch before you came in here? No? You had time? Yeah. Okay. All right. Let's switch it up a little bit because I know this. I just want you to follow along with me. This will keep you awake and also help you to learn it a little bit. And we'll talk through again by practice some of the things we've just done. So I've already got a project open, and I'm just going to create a create a new class in here, and I'll call it my my arrays. All right. Okay, so let's create a simple array, and we'll call this double salary actually let's call it double salary, and we'll make this just a straight up variable, right? And let's see here. How should we do this? What is a salary you guys would like to earn a week? Only $40 a week? $400 a week? $4,000 a week. All right, there we go. Show me the money. All right, so $4,000 a week. This is the salary per week, and we're going to call this one double weeks or week salary. Not that it's a week salary, but it's the week. Yeah. And we're going to declare what? How many weeks are in a year? 52. So we'll put 52 right here. All right, what do we do wrong? Oh, do you see what I forgot? All right, so you always have to add the brackets, right? Okay. So your salary is that, and then let's do double total Okay, so we're going to iterate. We're going to say int I. Wait a minute, let's back up. We have a constant here, don't we? 52. So let's say int or final int weeks equals 52. All right? And that means we could use weeks here. You guys following me, what I'm doing so far? Okay. So int I equals 0. I is less than weeks. I plus plus. I'm sorry? This is just practice. Yeah. Okay. So now we need to assign our value. So we'll take week salary. We give it I. We're going to assign it a salary. Right? So far, this will assign the value. This will assign 4,000 a week for 52 weeks. So let's do another one now to calculate, but let's use a different for loop. Let's do for loop of double weekly sal into week salary. You see what I did there? I'll do system out print line. And to make this more interesting, I'm going to say int week equals 1. Week now to get my week number to increment, what would I do? Right? All I'm using it is just as a notation for counting out the weeks, right? Does that make sense? So let's run it. Okay. So it spit out all of the data that I put in. But let's make it more interesting now. I want to know also what my year-to-date salary is, right? So I could say total plus equals weekly sal, right? Think about what that does. Total plus equals weekly sal. Total equals total plus weekly sal. That's what that plus equals gives us, right? Okay. And then let's say over here, my, what is the correct term for this? My year to date is my total. Oops, I missed a plus. Okay. Now what should it spit out over here for us? At week 1, it should say week 1, 4,000, and let's put a comma over here. Right? Comma, Year to date is, at week 1, it would be, what? 4,000. And then week 2, it should be 8,000, and so on, right? All right, let's test it. There you go. Wow. So over a year, you make a good salary. That's $200,000, $208,000 a year if you made $4,000 a week. You guys are ambitious. All right. So there's that. There's that one way. And what we've done, we've used the modified for loop to do this, right? Notice that, again, that the value that I am accessing with the modified for loop has to be the same as that of the array, right? Okay. All right, so what was one of the other concepts we looked at? One of the other ones we looked at was the initialization of values, right? So let's create a new double, and we'll call this monthly salary equals curly brackets. Now I could do just that, and that would be fine. Well, let's do it like this. So, what is it? We had 12 items, so let's make it 4,000 times 4. Oh, I didn't I thought I copied my comma, but I missed it. Okay, copy. All right, that's hard to read, right? Usually, what you'll find most Java developers do is they do this thing. They declare the curly bracket, and then they just come down and do that. I don't know if it's 12 times or not. I just copied and pasted ad nauseum to. All right. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow, that was pretty good. All right. There's something here though that you should see, and it should catch your attention. I wish I could say I'll give you extra credit if you could figure this out. That's the catch. In an array, it's totally appropriate. I wish I could, but I can't. I don't know, maybe I can. But I hate to incentivize class participation through. What was that? All right. Anyways, you're correct though. The last. Okay, that was weird. The last element in there that you see, or the last piece that you see, is that comma, and that's totally appropriate. Yeah, they're really loud, aren't they? It's very appropriate to have that last comma, and that's totally legal. And what that says to you is that, yeah, I could go ahead and add another element to this and it would be fine, right? All right, so we have our monthly salary now. We've used this initialization practice of using the curly brackets. And we've added an extra comma, which is fine. You could also take the comma out. That's fine too, right? I'm just going to leave it in there just so it drives some of you crazy because you're like, what? What is that? All right, so we have our double salary. Let's look at our modified for loop. Let's change this up though. Let's make this a float instead. Okay, so now we're going to do a for loop. We'll use a float, monthly, sal, semicolon, monthly salary, and I'm going to just spit it back out again. Let's see, we'll say monthly salary is. There we go. All right, so if we run that, this will of course produce at the bottom monthly salary as a float, right? All right. The other way we could do this though, let's say that, let's see, January, February. Let's say I don't get quite for February that amount. So let's say that just for February I only get 3,000, right? Because my boss is stingy. And so you can see there's the difference, right? But let's say I want to see what February is. And we know there's 12, and I want to access just that specific array index. So what would I do? Monthly salary. What subscript would I put in? 1. And this month is different. And there you go. So I've accessed it by the subscript, by the array indice. Okay. What were some other things that we just covered in our lecture for today? What are some other things? Let's jump back over here real quick. Oh, the length. The length. Say I don't know how long monthly salary is. Well, system out print line. I could say monthly and I could get the length of it. Right? So we run that. Now that'll tell us that the length of that variable is 12. I don't know why they call this time of the day every day. It's a student's high school. Okay. So that's the length character. Now let's jump back over to our slides here real quick. So we've talked about if they call again, it's got to be an emergency, right?
Yes.
Okay. So let's do this another way. Let's use a custom class and run it in an array. I'm going to take out just about all of my data here. And well, let's just create a new class because I think that'll make more sense. I'm going to call this my students. And I'm going to go ahead and give it a public static void main method. I'm going to leave that at the top just for visibility. But let's, in a student's class, let's see, we have string first name, string last name, string, let's see, major, and string date of birth. Right? Okay, so let's create a constructor. We're going to use all of these objects in our constructor. And because those are in there, I'm going to make all of these final to make them more immutable. Okay. I do want to create maybe a getter class. Some getter methods, I mean. So we'll use IntelliJ's feature again to create the getters for that. So now I have a class called students, and that's really not a good name because students means it represents more than one student, right? This is only one. This class only represents one, so I'm going to rename this and call it student. Okay. Now I have my student class, and inside of this I'm going to create now an array of students, because that makes sense. It's plural. Equals new students, equals new student, and we're going to have, just for simplicity, just 2 students. Okay, so I've created this array of students, but I need to populate it. So I'm going to create a method down here, and I'm going to say public static void populate students. And let's have it, instead of being void, let's have it return a student array. Okay. Now I really don't care what data is created in here, but this is just to populate an array of students. So I'm going to pass in my student array, because I just want to use that reference to the one already created. I'm going to create a for loop. Int I equals 0, I is less than 3, I plus plus, and now I'm going to say students subscript I, because I'm referencing, I'm iterating through the array of students that are empty, and I'm going to say new student, which is going to be first name plus I, last name. It's very original names, right? Plus I, and their major, computer science, and their date of birth. Unfortunately, these guys are all born the same year, so they're going to be All right. So I just have a very simple class static method that generates students. So I'm going to call populate students, pass in my student array, assign it back to my student object. Now I want to print the data. So I'll pass in my student array. And because I'm using this data type, I'm going to use my trusty brand new modified for loop, right? So I'm going to declare a student, my student, quote, students, right? You'll see what I did there? I did the same thing that we did in the other one. Instead of using double my value, now I'm saying student, my student, right? Because I'm going to iterate through each object. And I don't have a toString method down here, do I? Let's make a toString method. So let's do generate a toString. That looks good. Yeah, there's some data. And I'm just going to use the toString method. So we'll do system out print line, my student dot toString. Okay, so we're going to display the students. All right, does it make sense so far what we've typed, what we've done? Yeah. So we've got this custom class we've created to hold a type of data called a student. And now we've created an array of that custom type of data called student. We've done some using the enhanced for loops, how we access those array items. Let's print it out and see what happens. I think we have an error. Do you see that? What did I not? Missing a return statement. Return students. There we go. You have to have a return statement if you specify in the method signature that it's not void, it returns a type, right? You have to return that type. Okay, so let's run this again. It's down here doing its thing. Okay, index array out of bounds. What happened? So it gives us a line number, right? Gives us two line numbers. So we have an error that occurred at line 6. Line 6 says it calls this and it points to something at line 18. By the way, you can click on this right here, the hyperlink it creates for you. It'll take you right to that location. So we've populated students. What did we do wrong? Notice that our array index here is 2, right? So it's only 2 indices. I've specified where I could be 3, so it would go 0, 1, 2, and 2 indice doesn't exist. Only 0 and 1 exist, right? Okay, so let's run it again. Did you guys understand that error? How we got that? This is the very common error that happens with when you're dealing with arrays. Okay, so there it spit out the 2 student names. We've populated the data, right? All right, so let's take it a step further. Let's say we're going to use the scanner class. Ooh, that sounds like fun, right? All right, so scanner equals new scanner system.in. I'm going to use scanner, use delimiter. Whoops. There we go. I'm going to give my user a message, right? System out print line. Please, let's make it more inviting. Welcome. It's time to enter student information. All right. Let's think about how we're going to construct this. We want it to iterate and capture the number of students we're going to enter, right? So right now we have it set to 2, which is fine. But let's take out our populate method, because we don't really need that, right? We don't really need this particular piece of data. So now how are we going to populate this? What would we do? What would we do? Think about it. Let's break it down into a separate method. Let's say public static student array populate. Let's not do an array. Let's just do a student. Let's call it create, right? And we're going to take some information for creating the student. We're going to create with a string first name, string last name, string major, and string what? Date of birth, right? And this is going to return a new student. Right? So we just created a simple method that wrapped up the constructor is all we did. But what's another way we could do this? We could do this a different way, right? We could do it by passing in the scanner. This might yield some interesting ideas here. So we could say scanner I can't type. I'm going to take out the print line. Now think about what's happening here. Let's just leave it like that for a moment. Let's create a loop now for int I equals 0. I is less than what number? 2. I plus plus. And then what would I want to call inside there? Think about why I would do that. I've wrapped up a bunch of functionality now, right? I don't have to reprint every time, please enter, please enter. I've wrapped it up in a loop and called the information from that loop. And so then right here, I could say what? I could say student. If I could type correctly, I could say this. All right, student I, or students I, right? Does that make sense so far? So let's continue with it. What else would I... Let me just copy this to make it easier for us to do this. Please enter first name. Please enter last name. We'll just call that L, LNM. Please enter major. Make this MJ. We have one more, right? Please enter date of birth 0 0 dash 0 0 dash 0 0 0 0. What do you think? Now, what we've done, let me expand this window a little bit so you can see it better. What we've done is we've created a mechanism then for creating students, and we put the scanner in a loop so that we repeat some of this information. So we don't have to retype it, right? Yeah, we want repeatability in our code. And so the scanner taking it in, it's going to spit out a student object for us. And then that student object, we're assigning it inside the loop to the students. All right. So now comes the fun part, testing it. I always get nervous when I code in front of people because I'm always thinking man, these guys are going to look at me and go, he doesn't know what he's doing. All right, here we go. Please, welcome, it's time to enter student information. Please enter the first name. It's your lucky day, Leonard. I don't know your last name. What is your last name? What's that? C. Okay. Your major? Computer applications. Applications. I spelled that right, didn't I? Yes. All right. You don't have to give me your date of birth if you want to. What's that? 01 dash 02 dash. Ah. I know he's older than that because he's been in the military. So let's say 1995. Is that close? All right. All right, please enter another first name. Junilin. I don't ever pick on you. Did I spell it right? Junilin? Okay. What is your last name? In what? J-E. Okay. in your major? Compute. Whoops. Okay. And I'm going to guess. Okay. This is always dangerous when you guess a female's age. I'm not going to say like you're 12 or something, okay? Because that's just as bad. Good golly, I've dug myself into a hole. All right. 2000? No? All right, we're going to go with it though. All right. So there you go. So we've used it to iterate through something, to create an object on the fly, and so forth, right? Yeah. All right. What else could we do here to make it more flexible for creating students, creating objects? What do you think? Yeah. What about if we added another method in here? Public void student modify major. Student, see, scanner and scanner. Oh, there we go. Public static void. Duh. I don't know what I'm doing this today. All right. So let's make this a little bit more interesting. System out print line. Would you like to modify a student's major? All right. Where am I going with this? So let's say I've got the students out there that have been created. Now I'd like to modify a major. How would I do that? I've got the scanner. So scanner, next. I'm expecting a yes or a no, so I'm going to say string yes, no equals scanner. If yes, no, whoops, what is that? Wrong type of no. Uppercase equals ignore case. Y else turn null. We'll talk about how to handle that one in a second. Maybe a bad design decision there, but so let's say you answer yes. System out print line. System out print. What is the last name of the student? Scanner, next. String, last name. Is that? I just realized we need to do something here. We need to change. We need to pass in something that we're going to modify. Okay, that makes it easier. Sorry, class. I keep looking at my watch because I want to make sure we're not running over here. I want you to think about what I did here. I'm passing in the scanner as well as the students, and I'm returning the students, right? The student array. So we're going to find the last name. We're going to say for student, my student, colon, students, if my student get last name equals ignore case, last name, I'm doing now a basic search of the array, right? You see that? I'm searching by last name. Then we have the name of the student, right? So we're going to say please enter the major, the new major. Scanner next, string major, and we have my student. We don't have a way to change their major with the way our object is constructed. Do you all see that? We don't have any setter classes, right? Right? So here's the question, how do we handle it? One way to handle it is create a new student. And then we say my student get first name, my student get last name. We're going to pass in the major, or we're changing, my student get date of birth. That makes sense? All right. Now we have this variable created here. So now we need to assign the student back, right? Let's say my student equals ST. And then return students. Now, I'm going to let you know something. I'm not sure if that's going to work or not. The array index, where's that error at it's complaining of? There we go. The array index that we're using in an enhanced for loop, it's actually a reference to that memory location. And so when we're reassigning the value, I think we may get an error here. I'm not sure. But let's see. All right, so we got modify major. Now let's call modify major. We're going to pass in scanner and students. And now we're going to say students equals that. Let's try it again. Okay. Jim, you're the lucky guy. How do you spell your last name? L-A-C. Say again? S-I-N-A. And your major? Computer apps. You're just going to tell me, aren't you? All right, now we need a second person. He's hiding back there. Is it Edwin? Huh? Edwin, right? What's that? Edwin. He was back there like this. All right, Edwin. And it's... Okay. And then your date of birth. 8/23/2000. All right. Would you like to modify a student's majory? I misspelled. Yes. What is the student's last name? We're going to go after you, man. Edwin. Mactal. Mactal. How do you pronounce your last name? McDonald. Okay. All right. So it found you in the list. I typed it in correctly, so it's good, right? It iterated through my for loop. So I need to enter a new major. Let's just say we're going to correct the spelling. Computer applications. And there you go. But it didn't display it right, did it? So the catch here is I wasn't sure if that would work right, because we basically assigned it back to my student, but we never assigned to the memory location, and so we threw away the data in memory. Do y'all understand what I'm saying? All right, the way we could correct for that is is do away with the enhanced for loop here, because we want to be able to attach to the memory location, and I can't do that through an enhanced for loop. So int I equals 0, I is less than students dot length, right? I plus plus, and then I'm going to come over here and say students I students I it's supposed to be get first name. I don't know what happened. All right. And then this is, we're going to assign it back to itself. So students I. Now that would work, because now we're actually accessing the memory location and we're not throwing away the data. If we were doing this through a collection or some of the more advanced like things like array lists, we could get away with what we had written before. Okay. We got like 10 minutes. I'm going to run it one more time just so we can see if it's going to work or not. When you get to coding, and I don't know if some of you are dealing with this or not, when you're working on your homework assignments, you kind of iteratively work through it, and you're like, oh, I could make it better by doing this, and I'm going to do this, and you really get into it. And then before too long, you look at your watch and you're like, holy crap, like 5 hours have passed. And it's very easy because you get into the zone just thinking, and and then just time disappears. My wife gets very upset at me. The food's gonna get cold. I'm coming. Just one more second. 20 minutes later, are you coming or not? All right, so enter your first name. Let's see, who else can I? Steven. Is it Stephen or Steven? All right, what's your last name? Alon, like that? And your major? Computer apps. Birthday. You don't have to give it to me if you don't want to. What is that? February 20. Are you a leap year baby for real? Are you like, does this mean like you're 4 years old? You're 5 years old. Wow. You're a twin too? Wow. Wow. I just totally forgot. What year? 2000? All right. So now we're going to enter a second name. Joanne. I never call on you. All right, Joanne. How do you spell your first name? Okay. And your last name? Like that? Okay. And your major? Computer apps. Okay. It's a dangerous question again. It's up to you. $2,000? Okay. Would you like to modify a student's majory? I didn't correct that, did I? All right. Yes. All right. Who should I modify? Joanne or Stephen? Stephen? All right. What's Stephen Alonzo? Alonzo. Alonzo. All right. Please enter the new major. Let's make you math. Just math. And there you go. All right. So what we demonstrated are a number of concepts today, right? We used arrays with primitives. We used arrays with custom classes like the student class. We've used it with a for loop and an enhanced for loop. We've modified data in the array. We've spit it back out. We've done a lot of different things. All right, guys, read your textbook. There's some very good information in there, especially as your final exam comes up here in another 8 weeks. Okay. All right. Any questions today before we close? No? All right. There is a project that's due in 2 weeks, I think. Another project. It's not open yet? Okay. Start looking at it? Yeah. Yeah, I can do that. I can do that. In fact, I will go in and publish it now for you guys after I shut off the video. All right. Let me go ahead and close